Defects found could easily have been avoided using static techniques. Defects found later in the lifecycle, as we are all aware, become far more costly. Interestingly, defects found within the code generate more energy wastage and as a result impact the environment. Then there is the additional time spent by the developers coding fixes and running unit tests to address the underlying problem, producing release notes, migrating code, and then the test teams finally get a chance to retest the defect, as well as regression test the surrounding code. All of which presents a greater impact on the environment, and all of which could easily have been avoided through code reviews, documentation walkthroughs, etc. There is no configuration management process in place, nor even change and release management. Over 100 environments do not share a common build and do not accurately reflect production. The resources available in the existing Unix hosts or SAN are stretched and in many cases offer little flexibility to upgrade data servers to support additional functionality areas. Furthermore, there is a staff mentality of build it and they will come. For example, add new environments without reviewing what they currently have available to them. This model is not scalable to the business and presents a significant environmental impact. Replicating the overnight process utilises approximately 300 CPUs, all running intensively for nearly 16 hours, and this is replicated in a baseline and a build environment across two different instances of business areas, totaling in approximately 1200 CPUs. Running the test is often problematic and may need to be run several times to obtain correct baseline and/or build results. As a result of the points in this slide, projects fail or run at the very least inefficiently, presenting significant impact in financial and global environmental terms. As highlighted by the previous slide, the impact on the IT systems is significant, and our approach to testing should adapt to be more aware of this and take appropriate action. Again, I'll pause for a second to take another question from the audience. The client in question, what strategy do they have in place to address some of the issues that you have mentioned? This is a good question. Our client operates in a very dynamic and fast-paced market sector, and as a result, they do need to react quickly to change. And some of the processes need to remain fluid to a certain extent. The program leadership team is actively working to improve the development lifecycle, and since we have been on site, the evolution of testing is considerably different. The key focus is on efficiency. For example, technology use is high on the agenda to not only reduce the cost of the complex architecture, but also to force change in the testing focus and to drive through smarter testing techniques. Again, I hope that answers that appropriately. The following is not a definitive nor an exhaustive list, however this gives some insight as to how we as testers can help this situation. In many projects, particularly in multinational organisations, project staff are located in different locations, either in the same country or even overseas. In many cases, testing personnel travel back and forth for project briefings or update sessions or even knowledge transfer sessions. Going forward, the tester's mentality will need to adapt to consider their impact on travel and what impact this has on the environment. Gone are the days when businesses calculated the financial costs of staff time at airports, flight costs, and onward travel costs. We are now faced with our carbon footprint calculation as well. Video conferencing is nothing new, however this technology is continuously evolving, with companies achieving significant CO2 reductions, whilst also achieving cost savings on travel by approximately 20+%. An example of this was recently with HBOS boosting its own green credentials through the adoption of virtual conference rooms, with initial savings in the region of $50,000 between its Hong Kong and Chicago offices alone. Then there's the option to share desktops through WebEx, Lotus SameTime Connect, etc. to facilitate learning and idea sharing. Despite the promise of the paperless office, paper consumption is continuously rising, according to Fujitsu Siemens, Global Action Plan and DEFRA. 21% of prints disposed of were actually printed in the same day. Depending on the organisation's policy and risk, or depending on the nature of the organisation's business, the business may be able to incorporate a risk-based testing approach to reduce testing timelines and reduce redundant or less critical test cases. This should be defined at the organisational level, with tolerances agreed for test management decisions. Test managers should be responsible for commissioning sustainable and reusable environments. All infrastructure is a bookable resource and as such should be treated in this regard. Test managers should liaise closely with the development community from the initial concept or idea through information gathering and analysis stages, leading to the initial build or prototyping stages. Ensure all processes are as streamlined as possible to maximise benefits. Some organisations can look at alternative development models such as RAD or Agile to develop quickly and enter the marketplace with minimal effort, although this is very much dependent on the industry and the internal capability. Again, the testing approach in each scenario differs, and testing professionals are needed in support of this. It is important to be focused and perform impact analysis of change and direct testing accordingly. And of course adhere to the organisational risk strategy and approach. Haphazard testing is no longer acceptable within the organisation. Consumers demand quality products and services and now expect a leaner and greener supplier. So it's therefore important to complete a comprehensive infrastructure requirements gathering exercise, then design and plan accordingly to maximise utilisation. Share environments where appropriate with other projects, whether they're related or not. Order your work methodically, maximising efficiencies. Structured approaches also help in this regard. Documentation and code review should be adopted to understand the quality of the proposed solution early in the life cycle. As they do find faults earlier within the life cycle, if defects are found in the documentation analysis phases or through peer group discussion, there is little environmental impact. Likewise, code reviews offers the ability to understand the code in a siloed environment before releasing to complex architectures. They can also prevent fault multiplication. Introducing a fault in an application which triggers faults elsewhere within the system under test becomes very costly, not only in terms of manpower, but also throughout the infrastructure. Then of course there are various tool vendors who deliver computerized solutions to support business process testing. Existing roles and responsibilities are evolving to ensure environmental concerns are captured during the requirements gathering phase, prioritised accordingly alongside functionality and other business requirements, suitably tested throughout the development lifecycle, and any outstanding concerns are properly assessed, prioritised, risk managed and scheduled for future release. From a test analysis perspective, there will be greater timescales